Today I'm going to do a product review on the Kongber 30V 10A adjustable power supply. In this video, I'll be testing the main features to see if this is a product worth buying. If you're new to this channel, then make sure to hit that subscribe button. The power supply I'll be reviewing will be linked in the description, and let's get started. First impression on the packaging, there are no major dents or tears. So far so good. Once we're inside, we can see a user manual along with directions on how to adjust the voltage and current. At this point, we can spot the included pair of DC output wires as well as a power cord. Now this adjustable power supply is quite small, but how small is it really? When measuring its dimensions, it reaches a length of 8.5 inches, a width of 3.25 inches, and a total height of only 6 inches. Along with only a 1.2 kilograms of weight, makes it a potentially portable power supply. After switching on the power supply, we are greeted with a voltage, amperage, and wattage display. By turning the core's voltage knob, we can adjust the voltage in large increments. If we want to set the voltage to 12 volts, we can get close with the core's voltage knob, but with the help of the fine voltage knob, we can get it spot on. This power supply supposedly goes up to 30 volts, and when we get close, we can see that it exceeded our expectations by hitting almost 31 volts. A practical application for this adjustable power supply is if you just got a broken RC car from your friend and the battery is dead and you don't have a replacement on hand, you can just set the power supply to the same voltage from the battery to find out if everything besides the battery works before buying a new one. Now to adjust the current, we have one coarse knob and one fine knob, just like when adjusting the voltage. But the only key difference is, you have to make sure that the voltage is set to a minimum of 5 volts and short out the positive and negative terminals. At this point, you can go ahead and set the current from 0 to 10 amps using the fine and coarse adjustment knobs. Now you might be asking, what is the use of the current adjustment feature? Well, when using a battery as a power supply, if you accidentally short the negative and positive terminals, the wire will burn out almost immediately, since the current is only limited to its internal resistance. But by using this current adjustment feature, we can set the current to a safe value of, for example, 5 amps, and the power supply will regulate the current, thus preventing disaster. A better example would be if you're working with a low current boost converter. This boost converter has no current adjustment, which means while powering a fan, if you accidentally short the terminals, which happens quite often, the boost converter will get destroyed. But by setting the power supply to 3 amps, you can short it for a pretty long time while the boost converter will still survive. Now that the settings are out of the way, let's test the display to find out how accurate it is. For that, I'll hook up a multimeter to the power supply and set the voltage to a few different values while comparing the voltage from the power supply against the voltage from the multimeter. At 1.03 volts, the multimeter reads 1.05 volts, which is a voltage difference of 0.02 volts. At about 5 volts, we have a voltage difference of negative 0.01 volts. At about 12 volts, we have a voltage difference of negative 0.01 volts as well. At about 24 volts, we have a voltage difference of 0.02 volts. And overall, the highest voltage difference is 0.04 volts at 31 volts, which I have to say is pretty accurate. I also wanted to see how low the voltage can be set to, so after playing around with the voltage knobs for a while, I managed to reach 71.9 millivolts, which is quite impressive. The final accuracy test for the display is the current, which I'll be setting it to a few different values as well, while measuring it on a multimeter. At 1 amp, we have a current difference of 0.01 amps. At 3 amps, we have a current difference of negative 0.01 amps. At 5 amps, we have a current difference of negative 0.01 amps as well. And overall, the highest current difference is negative 0.14 amps, which would be problematic if it were to be a lower current, like under 1 amp. For example, when powering an LED that can take no more than 30 milliamps, high accuracy is very important, since giving it a few more milliamps that it requires can easily destroy it. The final test I'll be doing on this adjustable power supply is finding out if it can truly put out 300 watts of power. For that, I have a space heater that pulls 1500 watts at 120 volts. But since we'll be giving it only 31 volts, I'm gonna connect two heaters in parallel to hopefully pull 300 watts. While applying 31 volts to the heaters, it only drew 260 watts, so I brought an angle grinder which will be connected in parallel to the power supply. Now here's something interesting. Since the voltage is 31 volts instead of the advertised 30 volts, we are actually pulling 310 watts instead of 300 watts, which is 103% of the advertised rating. You gotta love it when a company delivers more than they've promised. Just for interest, let's find out how long this power supply can handle over 300 watts. To make sure the power supply doesn't overheat, I'll monitor the fan's on and off cycle. After 1 minute, the fan kicked on for the first time, while the power supply is still pulling 310 watts. The fan ran for a total of 30 seconds and shut for about 6 seconds before turning on once again. At 10 minutes, the fan was still running for about the same amount of time, with an on time of 29 seconds and a total off time of 4 seconds. After all the tests I've done, I have to say that this will probably be my new favorite tool, and I truly recommend this product. If you want to get one of these, you can find them down in the video's description. If you like this video, then make sure to hit that like button, don't forget to subscribe, and I will see you guys in the next video.